Alright, welcome back. It's Mr. Smith again. We're going to continue on with problem number 7. And this one says Kara and Sonny go to AMC. Kara paid $13 for one popcorn and two large drinks. Sonny paid $8.50 for one popcorn and a large drink. What is the solution? Hopefully you're starting to get to the point that you recognize that this is a system because we have two variables. What I've done, I've already pretty much set up my my let statement here. Hopefully everybody can identify the variables by now. I'm going to go ahead and set up my two equations. So we have one popcorn, so I'm going to write P plus 2D, because popcorn is P, drinks is D, and Kara paid $13 for that, so equals 13. Then we have Sonny, he paid $8.50. I'm just going to put my total amount on this side just because we're kind of accustomed to it being over there. And we have one popcorn and one drink. So one popcorn and one drink. And then all we have to do is solve it. This is actually a fairly easy, simple system because our popcorn will automatically eliminate if we subtract. So I'm going to subtract the two. 1 minus 1 is 0. 2 minus 1 is 1D. Then we have 13 minus 850. This is where a lot of you make small mistakes. I'm actually going to write this out to the side. So obviously 0 minus 0 is 0. 0 minus 50 we cannot do. We have to borrow. And then this becomes 10. 10 minus 5 is 5. Then we have 12 minus 8 is 4. So we get 450. Not 550, 450. Alright, do not, I'm sorry I had a lot of it cut off, I apologize. But do not forget how important it is to be able to do subtraction by hand, alright? Because this is going to be a calculator inactive section on the test and on the EOC. But anyway, we know drinks is 450, so I'm going to put D, and I'm going to put 450. And let's figure out how much the popcorn is. I'm going to go and use P plus D equals 850. So we have P plus D is equal to 850. We know this is 450. So I'm going to have P plus 450 is equal to 850. Then all I have to do is subtract 450 on both sides, minus 450. As you can see, this lines up perfect. 0 minus 0, 5 minus 5, 0, and 8 minus 4 is 4. So we know the popcorn is $4. So over here, I'm going to write popcorn, $4. And then the question is actually asking how much would it cost for 4 popcorns. So we have 4 times 4 is going to give us $16. Alright, so let's go ahead and go on to the next one. The next one is number 8. Pretty much it says we have 2 CDs and 4 DVDs cost $40. 3 CDs and 5 DVDs cost $55. How much is a CD and how much is a DVD? So again, I went ahead and set up the let statement for us. Hopefully we realize that our two variables, our two unknowns, are CD and DVD. Just again a hint, you can always look the last question and typically that will always help you figure out what it is. I'm just going to write my two equations. I have 2 CDs. So we have 2C plus 4D is going to cost $40. So we put equals 40. And then we go on to the next sentence. So we have 3C plus 5D is going to be equal to 55. Nothing is lining up perfectly. I'm just going to eliminate my C's. So the easiest number to get would be 6. I'm going to multiply the top by 3 and the bottom by 2. Remember, this is a strategy we used in class. I'm going to write this one right here. So we get 6C plus 10D. It's a bad C right there. There we go. And then 2 times 55, what is that, 110? And then we're going to do the same thing with this equation. I'm going to bring this one underneath it. We get 6c, and then 3, we get 12d, and then we get 120. And then we have to see if we add or subtract. Obviously, if they're both positive, we have to subtract. So 10 minus 12 is negative 2d. I kind of skipped this one because 6 minus 6 is 0. But over here we have 110 minus 120, and we get negative 10. So now we just divide both sides by negative 2, and we get d is equal to a positive 5. Negative and negative make a positive. So we know the DVDs. I'm going to write DVDs. I'm going to put $10. Then all we have to do is find out how much a CD is. And remember, in order to do that, we take one of our original equations, and then we solve. We plug in our answer. So we have 2c plus 4d is equal to 40. I'm going to take my 5. I'm going to substitute it in. And so we have 2c plus 4 times 5 is equal to 40. That's going to give me 20. 40, bring down my 2c in the front. The two things that need to move, 2 and 20. 20 is the furthest, so we're going to subtract 20. So we get 20 here, we get 2c there, and we divide both sides by 2. So c is equal to 10. So CDs, I wrote that backwards, didn't I? No, I didn't. Yeah, I wrote 5. I'm sorry, this should be 5. I apologize about that. That's what we had there. CDs are $10. So we're done with that problem. Again, hopefully you're starting to see that we're following the same type of pattern. Identify your variables, write your equations, and then solve the system. Let's go on to number 9. Number 9 is just our let statement, or our age problems. We have actually been working on these purposely since foundations. We have 2 individuals in this problem. We have Tim and Frank. Tim's age is T, Frank's age is F. I'm going to set up my 2 equations. It said the sum. Remember, sum means addition. So we're taking the sum of Tim's age and Frank's age, and it's going to be equal to 22. Then we have 2 times Tim's age minus 4 times Frank's age equals negative 28. And I'm going to multiply, because I'm going to try and eliminate my t's, because again, everything's lined up. Might as well use elimination. So I'm going to multiply this top equation by 2. And again, the reason why I'm doing this is because 2 times t is 2t. And now when you look at it, they'll eliminate. But we have to do that to everything. So we have plus 2f, and then equals 44. The only way we can get this to eliminate is to subtract. So 2 minus 2 is 0. Negative 4 minus negative 2 is negative 6f. And then we have negative 28 minus 44, which will give me minus 72. So now we divide both sides by negative 6, and we get Frank is equal to 12. Negative and negative will give us a positive. So to find out how old Tim is, because that's what the question asks, how old is Tim, we have to substitute this back into one of the original equations. Hopefully you realize that it's t plus f equals 22. We know Frank is 12. And for some of you, just by looking at it, you can tell that Tim is going to have to be 10. So we know Tim is 10 years old. Bam. Alright, so the last 2 problems I'm actually going to try and squeeze them on this video because they're pretty much self-explanatory. Hopefully this is something you can just check your answer real quick. Intersecting lines that intersect one time. Same line. It's two lines on top of each other. So bam, bam. And then you have another line right on top of that line. So bam and bam. Intersecting, you have one line going that way, and then you have another line going this way. And then parallel, or when you have two lines and they don't intersect, right? They're parallel. So as we can see, this crosses one time, same line, crosses infinite times. Sorry, I kind of messed that up a little bit. And parallel lines never cross. Any line that crosses is what we call consistent. So that, or any line that touches, so that touch, so they're both consistent. But the graphs that touch, they have another word that go along with them. So this only touches one time, so it's what we call independent. What helps me remember is that this I reminds me of one, so it only crosses one, and this one is dependent. And what helps me memorize this one is that we have two lines on top of each other, so they depend on each other. And parallel is just inconsistent. There's no other terminology with it, just inconsistent. In problem number 11, we have a sequence 2, 6, 18, 54, and it says write the next equal now equation. So when we look at this, hopefully we can see that we are multiplying times 3 each time. So times 3 times 3. It's kind of hard to see on top of that. And we need to write the next equal now. So that's the easiest one to write. So we have next equals now times 3. And I'm actually going to have to come back to this because I'm about to run out of time. So I'm going to stop here on number 11 and we'll come back to it and we'll continue on from there.